It's been 2 years next week since I went to visit Computer Reset. I didn't grab much, and yet I still don't think I have even gone through half of the stuff. I got there very late, just weeks before the last computer left the building, and just months before the warehouse got completely cleared out. Before I went there, I read online that all 486 boards were long since gone, and yet the first item I picked up was this VLB board. I found it in the repair room, on one of the benches in plain sight. There is of course a very good reason why no one else picked this board up, but I like a challenge. This board is heavily damaged with battery juice all over the board. It's not very likely that the battery had leaked when it was placed on a workbench back in whenever it was. So, being on the bench in the repair room, it's quite possible that it was faulty before the VARTA spilled its guts. I spent the entire weekend going through all the rooms and boxes at Computer Reset, but this was the only generic 486 board I could find. So today we're going to try to revive and restore quite possibly the very last 486 board from Computer Reset. If all goes well, we'll put it in a nice matching case and build a complete system. I really hope we can fix it, because I have some unusual and interesting plans for this board. So I think we're going to start this project with a smoke test. So I'll have a quick look online and check all the jumpers and skip ahead here. Okay, thanks to the excellent retro web, we now know that this is a Shuttle HOT-419. I think this is the R1 board. The DX266 was already on the board when I found it. We have actually tested this 486 in another project, so that is the only tested part. I checked all the jumpers and they are correctly set for a DX266. So no RAM and no keyboard. I used some deoxit and pulled these power connectors on and off a few times to get rid of at least some of that green nastiness. Okay, let's do smoke tests. Before we continue, I'd like to say thank you to PCBWay for sponsoring this video. I have been using their PCBs for years now, and I'm really happy with the level of service and the quality of these PCBs. This is just a few of the projects we have built on this channel. So head over to PCBWay.com and order some PCBs for your next project. Thank you PCBWay for supporting this channel. Okay, we're getting postcodes. We're not getting any beeps. We should have some angry beeps of some sort. Okay, let's check the reset line and the voltages. Yeah, reset line is fine. Voltages look okay too. So, let's add some RAM for the next tests. Okay, let's see what happens. Okay, we're actually getting something on the screen. Doesn't seem to be picked up on camera. We're getting some wavy lines moving on the display. And the post stops at 03. I checked online and code 03 is run BIOS checksum tests 32 KB. So that's not good. The corrosion is really bad. So for the next test I switch to 30-pin sims. Let's try again. Okay. Now it stopped at 0D. Oh, we've got beeps. 3 of them. And it's stuck at 13. Postcode 13 is system interrupt vector initialized. And 12 is 64 KB base memory test OK. So that is great. Well, the next step is keyboard controller checks OK. So I wonder if this is a keyboard error. I just realized this board is actually slightly newer than 1990. But the list I found online doesn't have a code 13. So code 12 is 64 KB base memory test OK. But there is no code 13. Well, I'm not sure what to believe online here. 3 short beeps is base 64K memory failure. Well, I did some reading, and depending on where I read online, I'm getting different information. So one page claims that it's initializing the chipset, and one page claims that 3 beeps are memory error. Another web page tells me it's the keyboard controller. The actual manual that came with this card is saying that the video display has been disabled Port B has been initialized. Next, initializing the chipset. But then it also states that 3 beeps is base 64K RAM failure. And it doesn't say which version of the Army BIOS it's referring to. So this is only partially useful. Well, if one of those sites are correct, it's the keyboard controller. And there are a lot of traces that are really bad in this area. So I guess that's quite likely. But let's do one final test before we start working on the board. So I have now hooked up a keyboard. It took a good while before I could hook up that keyboard in that really crusty connector. I used tons of deoxate and pulled it in and out a few times. Okay, let's try this. Well, that's interesting. Now it doesn't beep anymore. Now it stopped beeping and it's slowly going through the postcodes. I'm skipping ahead here, but it's taking its time. Okay, so when it reached 13, it started to beep, which is a bit weird, because those beeps corresponds to 12, if I'm not mistaken. Okay, so place your bets. Let's hope for the best and see if we can save this board. From the little information I have, the two most likely issues here is a bad trace to the keyboard controller or a bad trace to the RAM. Or maybe both and then some. Let's find out. Okay, let's start removing stuff. So these RAM sticks are tested in the Commodore 486 yesterday evening, so they are good. I was preparing the next video for that project and I immediately found at least 2 faults. These cache chips are really crusty, so we are definitely going to remove them to eliminate one possible issue. So this board can take 512K of cache. That's pretty good. Okay, there actually isn't much corrosion in the sockets or on these chips, but these traces down here, they are really bad. Why do I take on projects like this? Imagine all those people seeing this board at Computer Reset and probably thinking, nah, let's leave this one for Epictronics. Yeah, this socket here is completely filled up with that green stuff. So those error codes weren't pointing us in this direction, but I can already tell these cache chips aren't going to do their thing, because some of them are just completely filled up with that green stuff. So how about that BIOS chip? By the way, this is a 486DX ISA BIOS from roughly 1993. Yeah, how about those dates? This Opti chip here is from late 94, so that's probably when this board was made. Well, it sounds crusty, but no corrosion in that socket. Okay, time for some smelly vinegar. It starts to form bubbles right away. Yeah, it definitely reacts with this stuff here. Look at how thick that green stuff is on those resistor legs. Nasty! Well, I don't want to pour this stuff all over the board, because too much of this stuff here for too long will actually damage the board. So that's why I'm using a Q-tip and only applying where I can see some battery juice. So I will apply this stuff on all the green stuff on the entire board and let it sit for 5 minutes. Okay, I ended up washing the board too yesterday, before I ended the day. Now let's take a look at this board, or what's left of it. So this is as far as the corrosion went on this side of the board. There is still some corrosion left, and if we follow this edge here, this is pretty bad. I can't really see if these traces are damaged or not. But let's move along here. The board is kind of dull here, so it's really hard to see what the condition is of those traces underneath. And here's the corner underneath the battery. Looks pretty bad, but again, I can't really see the condition of these traces. But most likely these are still good enough. And moving along this way, then the corrosion stops here. So partially still reasonably okay on this side. But again, in the middle here, I can't really tell. Moving on to the other side. This is as far as the corrosion went. And same thing here, I won't be able to see the condition of these traces before I remove the solder mask. Moving along this way here, there is still some corrosion underneath these sockets here. So at least these two sockets, probably 4 of them, definitely have to go before we continue. It's same thing here. It's really hard to tell what the condition is underneath this dull surface. There is definitely corrosion on the traces on this side of the sim too. So at the very least we need to remove the solder mask on these traces here to have a better look at the condition. Moving along to the worst area. Do you guys see this trace here? Well, neither do I, because it's completely gone. From here somewhere, and at the very least to the power connector here, this trace is completely gone. And same thing with this trace here. And tons of these traces here are badly damaged. So, where do we even begin with a project like this? Let's just pick a starting point and start right here. And then slowly move in this direction here. So, to get access to these traces here, I'm gonna remove these 5 components here, this jumper here. And we'll see later how bad this area here is. Okay, let's be optimists here and try the desoldering gun. Well, I'm obviously an optimist taking on this project. Well, that was an empty pad, but I actually got that solder out, so let's try a few more. No, that didn't work. Let's try another one. No, I think I got half of that solder. Let's try the next one. No, that didn't work. We might as well do a thorough test here and see how bad this is, and then we'll change method to whatever works. Okay, that actually worked. So I got all the solder out in this through hole here. Yeah, the solder actually came out from this through hole too. I think this is an empty pad. Yep. Yeah, this one too. So, this board isn't as bad as the Commodore PC-10 project. Okay, the solder didn't come out from this through hole here. In that case, let's try with some flux. Heat. And some fresh solder. Okay, so I can actually push on these legs. And the components are moving. So I think this is working. This may look bad, but this is nothing compared to the Commodore PC-10 project. This solder here is actually melting. There are still pieces of corrosion falling off the board, even after 2 treatments with white vinegar and a proper wash. Yeah, this is totally working. Well, I'm not gonna pull hard on these components. I'm just gonna feel if they are loose, in case they are stuck in those pads. This board has seen enough horror. Okay, so about half of them are loose. I gave this resistor the same treatment, but it's still stuck. And these pin headers, they are still stuck too. Okay, in that case, let's try with the rework station. That pin actually didn't come out. It broke off. So we definitely need to replace these components. Those legs are so thin. One of them just broke off. I can still read the value on these resistors, so they are going to be easy to replace. But these diodes... Oh, that's almost readable. Well, I'll check the footage I took before I started this project, and we'll see if we can identify these diodes. I'm obviously going to install new diodes. Well, I suppose we should start with this edge of the board. This DIN connector here is definitely shot. There's no way we're going to reuse it. So let's take it off next. I'm not even going to bother without adding flux and fresh solder. Oh crap, bent legs. But the flux does a really good job at dissolving this crusty solder. With the Commodore PC-10 projects, we had to grind layer off before the flux would have an effect. Yes, this is going really well. Let's see if that connector is loose. It is. It just came right off. Now these pads are all okay. But this side here is pretty crusty. Okay, so this trace here is going in underneath the power connector here. So that connector has to go. Because although this trace is gone, it's actually showing us the way to where it's supposed to go. I'll use the same method as with the DIN connector. Flux, heat, and a splash of fresh solder. This connector is pretty badly corroded, so I'll see if I can find a spare. Okay, solder joints are nice and shiny. And that solder is coming right off. Well, we're off to a good start here, so I feel rather optimistic now. Probably unreasonably optimistic. Quite a lot of the solder is actually still left in some of these through holes. But these pins are really thick and those through holes are very large. Okay, that's too much solder left in those through holes to move on. So I'll mix it with fresh solder and have a second go with the desoldering gun. Okay, still some solder left after the second attempt. But we can't just use the rework station here, because that's gonna melt this connector and just make a bloody mess. So let's heat this side up here instead. This is the method I use to remove Dallas chips. They kind of have the same issue. No, it's not coming off. So if I keep heating this corner up, the board is gonna get bent. Let's instead use some flux. More heat. And more fresh solder. Let's see if this helped. Definitely did. That through hole cleared out very nicely. Huh, how unusual. That pin broke off. That's a first. Never had this happen before. Well, I suppose it's the corrosion to blame. Let's try again with the rework station. No, that's not working. Well, I don't like bent boards. So let's see if we can pry the plastic piece off. No, we can't. But I notice here that most of the pins are actually loose. So it only seems to be stuck in the middle here. I think it's just one or two of these pins here. Yep. I think these pads are okay. But I can't quite see because there's a lot of crap here. And the board is really dull. So everything kind of blends in together. So the next step is to clean it with some IPA. And maybe those traces are going to be more visible. Yes, I think this is working. I've still got some crap left here from the old battery, so I'll just remove that quickly off camera. Okay, with that cleaned up, let's try again. Well, it does get better, but obviously not great. Well, it does help me to see a few more traces, but it's not great. It's still very dull. Well, these components don't look too happy. They have some really badly corroded legs, and I can't see the traces underneath here. So before we clean this entire area, I'll remove these components too. I'm removing these components off camera, but I stopped and turned the camera on to show you something. So these components are so badly corroded, they're actually falling apart. So C6 here is a goner. I hope I can read those values. Otherwise we're gonna have to guess. Well, since two of the caps just completely fell apart in this area here, I decided to remove all the caps on this edge here. I took some pictures and took some notes. The next step is to add flux, tons of flux, and start cleaning this area. I'm going to use some wick, the largest tip I have. So where we have bare copper, the copper is gonna get tinned, like this trace here. Well, it cleaned up enough so I can see most of the traces. As you can see, there is nothing left of the solder mask in this entire corner. It's just completely gone. So this is just a bare PCB. I suppose that's why it's so dull. I don't have a Dremel tool, so I can't use one of those fancy green polishing tips. But I do have a grinding pen. So I'm just gonna start cleaning the remaining solder mask and corrosion off these traces. I decided to try something new. So I grabbed my microscope. I'm gonna try to do this by looking on the display of the microscope. Feels really weird. I've never done any work looking at a microscope display before. Feels really weird. But this is actually working. So I'm just very slowly cleaning off all the traces for two reasons. To stop any further corrosion, but also to reveal any issues underneath the solder mask. Tin the traces. Oh man, this trace is just completely disappearing. Okay, that was interesting. It does take some getting used to. Now let's tin what's left of these traces here. Tons of flux and a flat tip. That usually does the trick. Some of these traces are clearly broken, but I'm just gonna tin everything here. And then we'll check what traces are okay. And then we'll start checking what traces are bad. What a mess. Stupid VARTA. Okay, I think this is enough. The other side of the board wasn't too bad, so we're gonna leave it for now. Okay, let's start fixing some traces. So, right away, this one looks broken. And it certainly is. There's clearly two breaks here. So, how about this one here? There is a large piece missing here. So, we might as well reinforce it. How about this trace here? That's dead. Definitely broken. Apparently there is a small crack here. Well, we might as well just start with these. I'll try to add some more solder to these traces here. Oh, this trace is really thin over here. So I'm gonna solder it further away. There's plenty of room here, so I'm going to use some pretty thick wires here. I'll add some flux. And solder this end. Okay, that's a pretty thick wire. But why the hell not? There's plenty of room here. And same thing with this trace here. This third wire here is pretty bad. So I'm going to bend it. And make it go this way too. Now we can attach it at this end. Okay, let's make sure they are firmly attached. They are. Let's check for shorts. No, we're okay. And continuity. Yep, all three are good. So these guys here seem to be the power rail going to these ISA slots here. So those ISA slots were just partially powered. So how was that diagnostics card running? Okay, the next two are going to be pretty tough. So this trace here is going this way and then it just disappears. But by the looks of it, it used to be connected to this pad here. And same thing with this trace here. It's just completely broken off here. Then it's completely missing on this side here. But from what I can tell, it was hooked up to this pin here. And these 4 through holes here, they are for external battery. So we don't need to worry about it at the moment. But eventually we need to figure this out. So maybe if someone with one of these boards can help out and take a picture of this area here. But at the moment we can skip it and run without the CMOS battery. I guess we might be able to trace them out and make sure before we repair these 2 traces. The next one is as bad, but easier to guess. So this trace here starts off under the keyboard controller. And then it's coming this way here. And from this point here and all the way to this point here, it's completely missing. But we can clearly see where it has been, so this should be a fairly easy repair. I'm gonna place this wire underneath the board. That means we need something to solder it to. And by the looks of it, it's going to this cap here. So let's solder this cap in before we solder that wire. Well, there isn't much left of this cap, but it's actually enough to identify it as a 470 picofarad cap. I've got plenty of those. And my spare even fits perfect. At the other end here, this trace is going underneath the keyboard controller. So let's check if it's connected to one of the pins. And it is. It's connected to this pin here. On this side of the board, I'm going to use PTFE coated wire. Someone in the previous video thought this stuff was too thick, but it's actually quite thin. But you guys are seeing this with some serious magnification, so it probably looks thick. This wire is 30 AVG. I think we're going to make this wire shorter later on. But for now I don't want it to be in the way of soldering in other components. So I made it too long. Okay, let's check continuity. Yep, that's fixed. For a moment I thought we had reached the end of this project. Because this trace here is going this way, turns here, and moves in this direction. And then it just disappears. But then I checked some earlier footage, and luckily I was able to see that this trace continues. And then it turns here, moves in this direction, turns again, and connects to this trace here. So we're back on track. We are going to need to connect that bodge wire to the component at this end. So we need this component here. I think it's L2. Okay, the inductor is in the cheap and cheerful component tester. Let's see what it shows up as. Well, it showed up as an inductor, but that was actually all the information we got. So that's not very conclusive. This inductor doesn't have any markings. So I don't have any other option than just to assume that it's still okay. Which, to be honest, is very likely. Okay, L2 back on the board. Let's add bodge wire. Same thing with this wire. I'm going to make it longer than it actually needs to be. Okay, let's check for continuity. Yep, that one's fixed. Okay, the next, and I think the final broken trace on this part of the PCB is this trace here. This piece here is completely missing, so we need to connect these two pads. This is where the connector sits, so we're gonna need to bridge these underneath the board. That means we need to solder the connector back in. Luckily I found a nice connector in my stash. This connector is used, but it's in a much nicer condition. Okay, connector soldered to the board. So this through hole is actually not in use, but let's fix that trace anyways, in case this pad is connected to something else internally. It only takes a few seconds. I did a partial edit here and managed to see where these two traces are going, so we might as well fix them right away. That means we need to install components in these two through holes and these pin headers here. I wasn't able to identify these diodes here because they were too corroded. However, I think this is a pretty standard circuitry for the battery, so I checked on one of my other 486 boards, and that board used 1N4 148 diodes. So let's go with these. It's not ideal, and I also noticed that one of those three diodes was slightly different from the other two. So we know it's not a perfect match, but this is all I have to go by, so that's what we'll do. I realized too late that I shouldn't have made these bodge wires here exposed. I have installed these diodes here. They're not touching those leads. They are raised slightly off the board. But just for a good measure, I use some Kapton tape underneath, just in case. This pad here should be connected to pin 1. And this pad here should be connected to pin 3. Okay, that was the last bodge. I found a spare connector in my stash that is in a much nicer condition than the original connector. I think the next step is to reinstall all the components and do a test of this board. Let's start with this component here. It doesn't look great, but I don't have a spare. So let's just quickly test it. It measures pretty much 0 ohms. C5 here is identical to the cap we have already replaced. TC6 here is a 10 microfarad 16 volt tantalum cap, according to my notes. Same thing with TC1 and 4. We'll snatch a few from the next IBM project. The remaining caps on this board are marked P10 for Z. So that's 100 nanofarad. Got plenty of those. I don't have the correct type though, so I'm gonna have to bend all the legs. It's going to look a bit funny, but I think this is better than reusing old caps. Drenched in battery juice. Nah, that looks okay. That's not too bad. Okay, all removed caps have been replaced. Next up we have a couple of resistors. One 470R resistor here. R2 here is a 1K resistor. Okay, that was actually the last component that we have removed from this board. I'll make those bodge wires shorter later and glue them down to the PCB. This is good enough for a test. Okay, power, keyboard and graphics hooked up. As far as I can tell, we should now have a working keyboard controller and connector. I reviewed the earlier footage and one of the LEDs was actually very dim, so maybe that was indicating a bad power rail. But now we should have proper power in all the ISA slots. I've got freshly tested 4MB FP RAM sticks. I wasn't able to disable the cache. I checked the manual, but it only showed how to set different sizes, but nothing about disabling it. Hopefully that won't cause any issues. The BIOS chip is also back on the board with some deoxits. Okay, fingers crossed. Yeah, that LED isn't dim anymore. We're getting some postcodes. Nothing on the screen yet. It's going through the postcodes very slowly. We're at 10 now. 11. That took a good 10 seconds. Between 10 and 11. Oh no, we reached 13. And then it started to beep again. And it's still the same 3 beeps. We've got nothing on the screen. Not even those wavy lines. Okay, let's swap those 72-pin SIMs. And install some freshly tested 1 meg 30-pin FP RAM sticks. Okay, fingers crossed. Still going very slowly through the postcodes. Now we've got those wavy lines on the display. 10, 11. And no, the same issue. It starts to beep at 13. I did a quick check and the 3-volt line was completely missing earlier when we did the first tests. And the 12-volt line was very dim. So we definitely fixed something, but we still have an issue. Okay, at this point, our best bet is that one or more of the many traces going to the RAM slots have a break due to corrosion. Unlike the Commodore PC-10, which has quite thick and wide traces, this board has hair-thin traces going to the RAM. So the grinding pan is out of the question. Next I tried with my scratchy glass fiber pen. And it sort of works. But it takes absolutely forever, even to clean a very small area like this. This method is probably good if you only have a very small area to clean. In this case it would take many hours to clean all the traces. So that won't work either. The most popular method seems to be to use an abrasive rubber tip. However, I can't find any of those with the correct size for my grinding pan. They only seem to be available for a Dremel tool. I don't have a Dremel tool because they seem too large and bulky for what I do. But since that seems to be the only option, I went on Amazon and found this kit. This kit comes with a Dremel flexible shaft 225. The flexible shaft connects to the Dremel and looks to be pretty much as small as a grinding pen. I went ahead and ordered the kit and some of those abrasive rubber tips. The next step for this project is to remove at least 2 of these SIM slots and at least 4 of these cache sockets, and then clean and repair 1 or more of these traces here. If you're watching this video in the future, there will be a link to that video on the screen shortly. If you're watching this fresh, hit the bell icon below and set it to all to get a notification about the next video. I will end this video by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get early access whenever possible. If you want to help me grow the channel, like, subscribe and leave a comment. If you are a regular viewer, consider subscribing to this channel. Thank you for watching and I'll see you next week.